Hello and welcome to another math video. This is going to be a video about my first mathematical proof. My first mathematical proof was to prove a formula for the area of trapezoids. To give some context, I was in college, I was doing some Calc 2 homework, and it was something either related or maybe we were doing trapezoidal Riemann sums. Gotta be weird. We were doing Riemann sums, and I think we had reviewed trapezoidal Riemann sums. Hey, actually, I had forgotten at that point. I'd learned and forgotten multiple times throughout my schooling the area of a trapezoid, the formula for the area of a trapezoid. And so I kind of thought, hey, it could be fun to try and see if I could actually, instead of Googling it, try to see if I could figure out for myself. And that's what I did, and I think I had an answer in like less than half an hour. After that point, I took a big hiatus in math for like over a year, maybe close to 2 years or something like that. And the way I got back into math was I told myself, hey, you need to do the proof all over again from scratch, okay? And I did, and sure enough, both times, by the way, I Googled it to make sure I had the right answer, and I did. And then from there, from the second time I did this proof, I then did math on the side, and I've been progressively doing more and more math as time has gone on since. So let's get into it. Let's get into how I prove this. There are probably multiple ways to prove this. In fact, I actually know of a couple. I'm going to prove it the way I proved it back then, which isn't bad. It's a pretty good proof, I'd say. Simply put, I split the trapezoid. I'm saying a trapezoid, mind the drawing. The trapezoid is a mixture of a rectangle, definitely has a rectangle, and it has at least one, maybe two triangles, all right? And it has a set of parallel sides, of course, because there's this being a rectangle in the middle. We can reliably say this middle shape is a rectangle. It might just have one triangle, that's fine. The area of this triangle would then be 0, okay? But I'm just gonna say, we're gonna say area of a trapezoid is ATP. I know ATP is something else, okay? We're gonna say that, okay? Jeez. And we're gonna say ATP is the area of triangle number 1. I'm gonna call that AT1. Plus the area of this rectangle, I'm going to call that AR, plus possibly the area of a second triangle, I'm going to call that AT2. Don't worry, I already thought of this both times I did this proof. If there is no AT2, it's just 0. You just do plus 0, you're fine, okay? Alright, so we know if you did add up all these areas, you would get the area of the trapezoid, of course. Of course, now, what are these things? I probably should have mentioned it earlier, but I'm going to mention now. One of the things you need to think about when trying to create a formula is what are your givens? What a given is the information you are presumed to have. If you are going to indeed solve this, this is the information you need to solve it. Right now, I have no information, all right? But I'm going to fill in some information, and here's the thing, at this point, I don't know exactly what my givens are. I don't know what I'm going to use in the end. I don't know how simple I can make it. You might start with some rough formula, that is true, but you might then realize, wait a minute, these things could cancel, these things become redundant, and then you might start to simplify it, right? And of course, we always want to do that. We always want our formulas to be as simple as possible. So, what are the givens? Right now, I'm going to say what the basic givens for this stuff. Area of a rectangle, what do you need? You need the base times height. This side right here, I'm going to call this lowercase rb. Rectangle base. Remember, the triangles could be totally different. One other triangle might not be there. So we don't know, we can't say, oh, this is just TB. And this is also TB. No, this is TB1, and this is TB2. We have to say that because we don't know. Remember, I'm not just trying to solve one type of trapezoid. If that's your goal, if your goal is to try to solve a specific type I guess maybe that's another prerequisite. You have to narrow down exactly what you're trying to do. You don't have to know all your givens in the beginning, but you do have to know your goal. That is very important, okay? My goal is to solve any type of trapezoid, all right? Any type. And I'm going to try to do that to the best of my abilities right now. Okay. So we have these also. What are the, I'm probably going to want some more information. Okay, what do I need to solve the area of these things? I notice these two, because these lines are parallel, these two heights are the same. So the height of this rectangle is the same as the height of this triangle. And will always be the same, because that is a definition of a trapezoid, is it has two sets of parallel lines. And so all three of these shapes share the same exact height. So to recognize that, I'm just going to say H. Let's start diving into what these things are, right? Okay. Because so far these are not reasonable. If you want these to be your givens, you can stop right here. You can stop right here, and I need to know the split areas of everything to solve this trapezoid. I don't want to stop there. I want to see if I can get this as simple as possible. You want to try to solve something with the least amount of information required, all right? Just so it's just better that way, okay? I'm not going to get too far into it. Let's get this done. We know for AT1, that's going to equal 1/2 TB1 times H. All right, AT2. I should probably draw this, whatever. Try to make more space, but oh well, what are you gonna do? 1/2, there you go, H times TB2, it doesn't matter what way I draw it. How about this, up here? Perfect, right? So AR, I'm going to say is RB times H. So I know what all of these are. All right, excellent. So I guess we'll add them all up here. Why not? So I'm going to say ATP equals 1/2 TB1 times H plus 1/2 TB2 times H plus RB times H. So one of the things I'm noticing right away is all these H's are the same, right? I can factor all of them out. So I can say ATP equals, that's just something that hits me right away, equals H parentheses 1/2 TB1 plus 1/2 TB2 plus RB. All right. So far, I am correct. Okay, you could use this to solve the area of a trapezoid, but it's not good enough. Okay. And if you Google area of a trapezoid, you're going to get a different answer than this, because Google has the simplest, best answer. In order to simplify this, I have to get a little creative now. So down here we have RB. This whole length is equal to TB1 plus RB plus TB2. And this here is just RB. All right. So already what I'm thinking of, what if I say this entire length here, oh, bear with me. I'm going to call that something. I'm going to call it ATB. Oh, excellent. ATB. I'm going to still call this one up here RB. What I'm going to do now is I'm going to say ATB1 plus, sorry, not ATB, plus TB2. I'm going to say this equals ATB minus RB. ATB minus RB. The reason why I'm saying this, you can see pretty clearly, right? This includes everything. So if you get rid of the RB, what do you have left? You have ATB1 and you have ATB2, okay? I'm gonna go back here, and I see these 1/2s. Now RB doesn't have a 1/2. Okay, that's fine, I can ignore it. We can rewrite this. It's gonna equal H parentheses 1/2 more parentheses TB1 plus TB2 close parentheses plus RB. All right. All I've done is I've taken the 1/2 out of these, but not out of the RB. Oh, sorry. Close. There's a big. Let me draw brackets. I think you guys can see where I'm going. I'm going to substitute this information for this information, trying basically to make it as if I don't need to know what TB1 and TB2 is to be able to know what the area of this trapezoid is. It's irrelevant, all right? I just need to know the general length of the bottom, or this side, one of the parallel sides, and then the other parallel side. ATP, we're going to rewrite this as H bracket 1/2 parentheses ATB minus RB close parentheses plus RB bracket. Okay, so far mission accomplished. This doesn't fit the cap. What I have done is I've made this formula better so far. However, it's still kind of large. Maybe I could make it smaller. And you know what? I'm seeing the same value twice here. I'm seeing some stuff. I'm thinking I can make it smaller. I already have a plan of attack. ATP, all right? What I'm going to do is I'm thinking this 1/2. Let's put it back in, right? H, this time parentheses, 1/2 ATB minus 1/2 RB plus RB. Close parentheses. I'm looking at this, the negative 1/2 RB plus positive RB. I'm going to say ATP, the room, the dreaded room thing I was so worried about, equals 1/2 ATB. I was like, wait, ATP? No, B. Maybe the letters, maybe the things I substitute, maybe what I call things could be better, right? Because this cancels, this is going to be equal, we know, negative 1/2 RB plus positive RB, that's just going to be positive 1/2 RB plus 1/2 RB, close parentheses, okay? And a little last thing before we're basically done, we're going to factor, I see these 1/2 here, I'm going to factor that. I love factoring stuff out. I'm going to redirect our focus here. I'm going to say ATP equals 1/2 height times ATB. Bear with me here. I know I'm drawing this slanted. Plus RB, close parentheses. And for all your Googlers out there, I'm going to replace these things. Okay, I'm going to call ATB, I'm going to call that B1, I'm going to call RB B2. We're going to rewrite it over here. So just remember, I'm going over here now. Ready? Okay, let's go. ATP equals, I'm also going to write it in a format that's maybe nicer. I'll put the H on the side. I don't know. Maybe Google will have it this way. It doesn't matter. Come on, obviously that doesn't matter. Plus, I'm not erasing anything with my hand here, right? Plus B2, close parentheses, times H. Oh, we're going to make it nice. Over 2, all over 2. Or whatever over 2, doesn't matter. And that is our formula for area of a trapezoid. Thank you guys for, if you stuck through to this part of the video, all right? Or, actually, thank you if you've watched any part of this video and you decided, hey, I want to figure out, maybe you got to here and you thought, okay, wait, let me try to do this. Let me try to see if I can figure this out. I think that's amazing. I think I encourage people to try to question things generally, what you've learned in school. Of course, bear in mind, you should always make sure you've done stuff right. So, what if you try to do this by yourself, either watch this video to the end after you're done or Google it, right? And you should hopefully arrive to the same conclusion. You should hopefully have a fun time doing it. I think that's it. All right. Bye, guys.